Hi, this is Sushant Madhubalan. Welcome to this video where I'm going to talk to you about my visualization project. Picture this. You are having two credit cards, one from bank A and another from bank B. You decide to close the credit card from bank A due to some reason. Let's say the limit was too low or they do not have great deals. Just when you're about to start the procedure of terminating the card, you receive many calls and emails that suggest really good offers in this bank Ace card so that you're retained. Sounds familiar, right? A part of this comes from visualized tools that help bank managers analyze customer data and then try to retain them. Today, we'll be talking about one such dataset, the customer credit card churning dataset. So as you can see, this is the home page. We have about 19 variables, which is a good mix of categorical and numerical variables. I will start by giving information about uh, each of these variables. Also note that this dataset contains around 750 entries uh, that have been picked at random. So let's start with the categorical variables. So we have the attrition flag, which is set to 1 if the account is already closed, else it is set to 0. Then we have the customer's gender. We have the months inactive in the last 12 months, which is, the number of consecutive months a customer was inactive at the bank. We also have the dependent count, which is the number of dependents that the customer has. This kind of indicates how many people are dependent on this customer for the finances, right? We also have the income category, which ranges from $40,000 to greater than $120,000. We also have education level, marital status, and the card category. The card category is it ranges from blue to platinum, where blue is the most basic credit card that you can get at the bank. We also have a couple of numerical variables here, um, like credit limit, which is the maximum amount a customer can spend using the credit card. We also have the months on book variable, which is the number of months that the customer uh, is with the bank. We also have the average open to buy, which is let's say that a customer has a limit of $1,000 and has spent $200 this month. The open to buy would be 1,000 minus 200, which is $800. Dollars. And since this is an average, it is an average of the last 12 months. We also have the total relationship count, which is the number of products the customer uses at the bank. So he could be having a loan, he could be having another debit card, and so on. So we also have other numerical variables like contacts count. So this is the number of times the customer has contacted the bank in the last 12 months. A greater number of contacts count could kind of suggest that the customer is not very happy with the service of the bank and has been reaching out to the bank pretty frequently. We also have the total amount change ratio from Q4 to Q1. It is basically the ratio of the total amount transacted in the quarter 4 to the quarter 1. So if this ratio is less than 1, that is Q4 by Q1, if it is less than 1, it means that the customer is spending a lot less in Q4 than Q1. Similarly, we also have the count change, which is a similar ratio from quarter 4 to quarter 1. Then we also have the total transaction amount in the last 12 months and the total transaction count in the last 12 months. We also have the average utilization ratio, which is the ratio of the credit used to the credit limit. Then we also have the total revolving balance. It is basically the debt amount. So let's say we are in March, right? So the utilization, so the revolving balance for this month would be debt in February plus credit used in March minus debt paid in March. So it signifies the amount of debt that a person has. So this data set has been picked up from this particular link. Moving on to the actual implementation. So I think let's start with the scatter plot. It gives a really interesting insights into the data. So the scatter plot is capable of plotting any combination of categorical as well as numerical variables. Let's plot a graph of the average utilization ratio versus the attrition flag. So on the y-axis, we have the average utilization ratio, and on the x-axis, we will have the attrition flag. Yeah, so basically in this interface, a person can choose the axis and can choose the variable, and it gets plotted on this area. So right now we have the average utilization ratio versus the attrition flag. So as you can see, most of the attrited customers are somewhere here, right? So their utilization ratio was a lot less, and they ultimately left the bank, right? So a bank manager should ideally be targeting this particular chunk of customers so that they get retained. So maybe you can say, so when you hover over these points, we get the value. So this is an existing customer with a utilization ratio of just 0.019. So probably this is some cause of concern, and they should really reach out to this customer. Similarly, these are the attrited uh, customers. Now let's try average utilization ratio versus the credit limit, right? So on x-axis, we will change it to credit limit. So this is a plot of two, numerical variables, and we can see this really, it's kind of a parabola. So as you can see, this is a distribution of average utilization ratio versus the credit limit. We can see that there are some customers with a very high credit limit but low utilization ratio, right? And also there are customers with a very low credit limit but a high utilization ratio. So this could imply that the expenditure among all the customers may not be very different, right? A person with a very high credit limit may be spending the same as what a person with a very low credit limit is paying. So let's also try average open to buy versus income category. On the y-axis, we will have the average open to buy, and on the x-axis, we will have the income category, right? Income category. Yeah. You can see that uh, this is a numerical versus a categorical, right? So we can see that as the income is lower, like the open to buy is a lot lower as well. And for when the income goes beyond 120K, you can find a chunk of people even here, right? Similarly, we can plot for uh, categorical versus categorical. So we have explored numerical versus categorical, numerical versus numerical, and this is numerical again versus categorical. So if you take two categorical variables, like on the y-axis, let's say we have cart category, and on the x-axis we have the dependent count. So this is a categorical versus categorical kind of data that is being plotted on the scatter plot. Now I think we can move on to the bar and histogram. So again, we have a drop down where a user can select one of these variables. And when a user selects a categorical variable, it plots a bar graph. And when one selects a numerical variable, it plots a histogram. So let's start with bar graph. So I selected gender and I got this bar graph, which is the number of males and the number of females in the having credit cards, right? So some of the features that this offers is that when you hover over the bar, you can actually see the value, and also the bar gets highlighted in this maroonish color, right? Similarly, you can see education level. There are a lot of graduates in this bank, and couple of, I mean, very less for 42 postgraduate customers, right? So this is a distribution of the education level uh, at the bank. We also have the attrition flag. So as you can see, there are 670 existing customers and close to 79 attrite customers. So these are the customers who have already left, right? So we should really be targeting these customers to retain their credit cards. So we also have marital status, which is married and single and divorced. So the highest number is married, which is 429 in this data set. We also have card category. So here, I mean, the number of customers in blue is the highest. It's almost like 90%, right? Um, so the focus could be to shift customers from blue to, let's say, gold or silver, um, by providing perks and benefits and points, loyalty points, and stuff like that. Then we also have yeah, months inactive in the last 12 months. So this is also a distribution of the number of months a person is inactive in the last 12 months. So for there are many 189 customers who were inactive for 1 month. So now we can move on to histogram. Uh, so let's start with credit limit. So as you can see, even in the histogram, when I hover um, over these bins, I get to see the value as well as the bin gets highlighted, right? Um, Further, these bins are equivalent, and we can also change the number of bins by dragging. So when you drag towards the right, it increases the number of bins. When you drag towards the left, it decreases the number of bins. Also, there's a limit on the number of bins that it can be increased. So I cannot increase it beyond 18. This has been done because it's, practically, it's not really practical to have, 25, 30 bins for a small range data set. This is the measure of the depth. So as you can see, it is kind of a bell-shaped curve, but there's a huge chunk somewhere here. So uh, I mean, there are a lot of people with low depth, but there are quite a lot of people even somewhere in the middle here with a high depth. Then we also have the average open to buy. So, if average open to buy, as I had discussed earlier, is that if a person has a limit of $1,000 and has spent 200, the average open to buy is 800. So as you can see that the average open to buy for most of the people is low, which means that they are using it a lot, using the credit card a lot. And as we go down, the average open to buy decreases, right? Similarly, we also have total amount change from Q4 to Q1. This is also a bell-shaped curve. Many of them in the zero point 0.7 to zero point 0.8 ratio. Perhaps the bank should target this crowd, uh, so that they really increase the ratio more than one. So if the ratio is less than one, it means that the transaction amount in Q1, sorry, in Q4 was less than Q1. So if these people here have spent more in Q4 than Q1, so the priority should be shifting this crowd to greater than one. So even the count change follows a similar pattern, and they should really be targeting these customers to shift them greater than one so that they can get maximum utilization. So as you can see, I'm dragging and it kind of increases the number of bins. And when I drag left, it decreases the number of bins. And you can see that this huge chunk of 388 customers are in the range zero point 0.8. Then we also have total transaction amount, which again is a kind of a bell-shaped curve, and it follows the same pattern. Customer's age. So customer's age, uh, okay, let me just, yeah. So if we increase the number of bins, we can see that most of the customers are in this range. So it's around 45, 40 to let's say 50. That would be the range of the customer's age. So you can see an even clearer distribution. So this is somewhere around 40 to this is maybe around 50. Most of the customers lie in this range. So this is how we can use these bar graphs and these histograms and the scatter plot to get a good idea of what is the behavior of the customer and what is the general sentiment, whether the credit card is being used properly, and what kind of customers we really have to target to retain maximum customers among them. So with this, I would like to conclude this video, and yeah, thank you.